Accidents involving motorized vehicles and utility poles are far too common. If an energized wire comes down, a minor accident can become fatal.
If you respond to a call in which the operator of the vehicle is inside, then direct the driver to remain inside until the utility company confirms that the lines have been de-energized.
Sir, stay right there.
In situations where occupants require immediate medical attention or the vehicle is on fire, other action needs to be taken. If the driver is capable of operating the car, instruct him to do so, moving it at least 30 feet from the wire. Something to consider is what's called coil memory. If a wire is pinned by a vehicle, when released, it will recoil back toward where it's connected. So keep a safe distance, at least 2 pole lengths, and don't be anywhere near the path the wire may take when it recoils. What if the vehicle can't be driven? Instruct the driver and any passengers to stay inside until the utility company can de-energize the lines.
We're gonna get you out in a minute.
If the vehicle is on fire and there's an occupant, you have an extremely dangerous situation. From a safe distance, see if you can put the fire out using dry chemical extinguishers. Keep in mind, the chemical spray will only carry 15 to 20 feet, so you have to be aware of how close you get to the fire. Otherwise, you can become a victim. The use of water should be avoided. Remember, water is a conductor, so even with a fog spray, the potential for electricity being conducted through the mist is great. The same warning applies to using foam, which unfortunately can also be a conductor. Once the fire is out, don't forget that the downed wire may still be energized, so stay back and keep any vehicle occupants inside until the utility company is on the scene and eliminates the electrical hazard. Where current flows into the ground from an energized source, at first the voltage drops off rapidly, but then levels off and dissipates evenly as it continues to move away from the point of contact. But can you be sure of the voltage? No, especially since moisture and other factors in the ground play a role. Err on the side of caution and maintain your circle of safety at 30 feet.
As you take each step, the voltage in the ground between your feet will vary. This is defined as step potential, the voltage difference from one foot to the next, and it can be significant enough to stop your heart. When both feet are touching the ground at the same time and separated, current can flow up one leg and down the other, with the potential of electrocuting you. To combat this danger, take very small shuffle steps with feet close together and always keep in contact with the ground. An alternative method of movement is to hop, taking very short hops with both feet together and making contact at the same time.
If you're a firefighter, puddles of water are often present, or the water has saturated the ground, so the danger is increased. And please keep this in mind. Don't count on rubber boots protecting you. Under many conditions, they won't, so take every precaution. With this knowledge, let's return to the emergency involving the burning car. If the occupant is uninjured, instruct that person in how to exit in a way to minimize the danger. Leaving the vehicle without making contact with the ground is difficult. You may need to direct the occupant to find and clear the easiest exit point.
Sir, pay attention to me. You have to get out of the car, but you have to do it a certain way. You have to jump out. Don't be holding the car and touching the ground at the same time, all right? Once you jump out, hop away. Okay, go ahead.
Remember, it's critical not to touch the vehicle and the ground at the same time, but to hop out with both feet together. Because of step potential, small hops should be used to reach a safe area.
In dealing with these highly volatile situations, you have to keep a cool head. The instinct to rush into action to suppress the fire can cost lives, including your own.
The most frequent cause of electrical contact from vehicles is construction equipment, which through unawareness or misjudgment gets backed into or catches utility poles and overhead wires. If a vehicle becomes energized, everyone occupying it should stay put and remain inside. The operator can move the vehicle away and out of danger if it can be done safely. Everyone on site needs to keep well clear of a vehicle which has snagged a power line. If the vehicle can't be moved clear of the wire, keep away until the utility company de-energizes the line. If the situation dictates that the operator has to leave the construction vehicle, make sure the procedure for jumping off and then shuffling or hopping away in short movements is followed. If utility company equipment is burning, allowing it to burn is the best course of action. Once damaged, it will be replaced, and no utility company wants responders to risk their lives to save a piece of equipment which won't be repaired. Attempting to extinguish a burning pole-mounted transformer from the ground or a ladder is usually futile and extremely dangerous. Remember that since electricity seeks a path to the ground, the hose stream may provide that path through your body. The utility company people will advise you on what to do when they arrive. They may very well direct you to let it burn, or wait until power is shut off before trying to suppress the fire. This doesn't mean there aren't actions which can be taken to provide a safer outcome. There are usually numerous exposures, such as trees and buildings, which need to be protected from fire. Also, securing the site includes keeping the public at a safe distance until the emergency is resolved.
This is a pad-mounted transformer. Similar to the transformers on utility poles, high amounts of current move through this structure, and both contain oil for cooling, which can present an additional hazard if released.
If there's a fire, don't use water or foam to suppress it. Use only dry chemical. Keep a minimum 30-foot circle of safety between you and any energized objects. And again, it's less expensive to replace damaged equipment than to repair it, so safety is the critical issue.
Much of the electrical distribution system, especially in urban areas, is underground. Any number of environmental changes can trigger fires in the vaults and passages housing electrical wires and equipment. How do you deal with these situations?
If you detect signs of fire, but don't observe any equipment or work activity, most likely no one is in the underground vault or manhole. Don't make any attempt to investigate further, but report what you've seen to the utility company. When work is being done, as a rule, someone from the crew will be above ground. Instinct may tell you to rush down into the chamber, but don't. Because you have no idea of what may be energized, and because of poor visibility, make sure the utility company has been notified and wait for them to de-energize the area. Again, you should stay well clear of the opening, because underground gases and damaged cables are capable of exploding. Once power has been shut off, with full protective equipment and breathable air supplied and monitored, the chamber can be entered. All the rules for confined space entry must be followed, and extra caution has to be taken to avoid sparking, such as from flashlights being turned on or metal scraped, because of the possible presence of combustible gases. Most electrical fires are caused by excessive heat from wires, machines, and appliances, which have been overloaded or poorly insulated. When fires break out in buildings, you're almost always exposed to energized electrical wiring and power lines. Industrial facilities, such as this, have heavy-duty electrical systems with equipment operating at over 10,000 volts. Recall that residential systems mostly have 120 and 240 volt service. While much lower than industrial voltage, it's still very dangerous. Here are some guidelines which should be followed at all times. When you enter a building, you may want to keep power on to aid your visibility in investigating the fire. However, because smoke may still limit your visibility, keep your palms turned inward. Why? If you come into contact with any energized sources and you experience muscle contractions, your arms and hands will be pulled toward your body and away from the source of electricity. Many firefighters believe that when responding to fire emergencies, the pulling of an electric meter is an acceptable procedure. It isn't. Meters can arc and explode. What you want to do, if possible, is locate the main breaker box or panel and shut off the power from there. And when doing so, turn away from the power source to avoid being injured if it arcs. All electrical wires are approached as if they were energized. And as shown earlier, even if coated, don't make the mistake of thinking that means they are insulated. Firefighter gloves are not designed to handle energized electric lines. Don't be fooled into thinking it's safe to touch the lines. It's not. Nor is it safe to use any of your tools to cut power lines. This attempt to de-energize power to the burning structure is extremely dangerous.
As with all the earlier situations we covered, the guidelines for parking, public safety, and safe distances need to be followed upon arrival at the emergency site.
Even after you have cut power, take care not to come in contact with machinery or appliances. Especially in commercial and industrial facilities, there may be alternate or emergency sources still supplying electricity. When you're fighting any kind of fire with overhead electric lines in the area, the same guideline of keeping a minimum safe distance of 10 feet from the energized line applies for any ladder or bucket. This guideline also applies to any equipment and tools you're using. So make absolutely sure you're keeping a safe distance before jumping into action. Because of these dangers, only essential crew members should be anywhere near vehicles exposed to this risk. As previously shown, anyone working on the vehicle must avoid any contact with the ground because of the possibility of electrical arcing. Large-scale fires involving multiple vehicles and different companies and agencies compound the complexities in responding. Having an action plan in place ensures that everyone is aware of the location of power lines and other electrical sources, so coordination of all parties' actions create a safe outcome. When the utility company arrives, they'll probably cut the service wire taps on the utility pole or open a switch to de-energize the lines. Only when they test to make sure all sources of electrical energy are removed will you get an all clear to move about safely.
An electric power substation has transmission and distribution lines coming in and out of it. Typically, some of the components include a control building, large transformers, structures to keep the lines elevated, and circuit breakers. Both transformers and circuit breakers are filled with oil, which insulates the internal electrical components. If a fire breaks out, the high voltage levels mandate special guidelines for responding safely.
The utility company control center will most likely be aware of a problem at a substation and immediately dispatch personnel to the site. However, you may be on site first, and if so, be sure to call the utility company just to make sure that they're aware of the emergency. Under no circumstances should you attempt to enter the substation before the utility company experts are on the scene. Because of the high voltage and possibility of explosion, the danger zone is extended much further, a minimum of 300 feet. Make sure your vehicles are parked at a safe distance and be careful to avoid putting them underneath a power line. When utility company personnel arrive, They'll provide guidance to set up a safe corridor of operations in approaching all the structures and equipment.
This side is dead, all the way up to Talleyrand. The other side behind us is energized. Don't be shooting anything on the other side.
They may decide to let the equipment burn itself out while directing firefighters to protect exposures. In situations like this, metal ladders should not be used. Only ladders made of non-conducting materials. A good guideline to follow when inside the substation is to have no equipment extend beyond shoulder height, because any overhead facilities may be energized. Most times the fire is coming from oil in circuit breakers or transformers. Because large amounts are housed inside, it's a major concern which requires special guidelines. With equipment de-energized, the oil fires can be extinguished by using protein foam sprays and water fog streams. Never use a solid stream of water on oil or any pools of oil, which could actually spread the fire. However, the fire may continue burning inside the equipment. Reignition is not uncommon, and the oil may burn for an extended period of time. Burning could start and stop for days. Be aware that the oil vapors are also capable of exploding. So full PPE and safe distances from equipment need to be maintained. The utility company may de-energize only the affected section within the substation, choosing to keep as many customers as possible in service.
A big problem was a lot of this stuff was energized when we arrived. So we had to wait on the electric authority to verify that this was de-energized. They were able to de-energize this bank that we're under, but not totally the entire facility here. We marked off an area we felt safe to put foam and our Purple K dry powder extinguishers, try to knock it down.
As previously stated, equipment which has been severely damaged by fire most likely will not be repaired, and the utility company doesn't want anyone being injured in trying to save it. Another danger, glass and ceramic insulators under intense heat can explode when water is applied.
There are other hazards to be aware of, such as toxic gases which can arise from insulation in batteries. So it's best to limit the number of people involved to only the most essential and to confine the fire within the substation fence line. These huge transmission towers are constructed in right-of-way corridors, which isolate them from traffic, construction, and trees. Even so, a large fire and smoke can extend upward far enough to present a different and dangerous scenario.
At a distance of approximately 6 feet, with enough heat, the particles of smoke can trigger arcing, with an intense burst of electrical energy flashing to the ground. So when you recognize these conditions forming, put at least 100 feet of distance between you and the fire. As shown earlier, a tree in contact with an electric line can be energized, as well as the ground around it. This situation involves step potential, and with all this in mind, everyone should be kept at least 100 feet away from the downed tree.
Generating stations such as this, which burn fossil fuels to produce electricity, rely on you to bring fire emergencies under control.
In the case when you guys come down here for an evacuation, this is where everybody's going to meet.
If such a facility is in your coverage area, you need to be meeting with the utility company to discuss emergency preparedness to deal with possible dangers associated with the generation plant.
Inside these generating stations, you could encounter hazards from water, steam, natural gas, and toxic substances.
You need to familiarize yourself with the plant layout, know the location of chemical and oil tanks, hydrant and fire pumps, and so forth. If a fire starts in a generating plant, you'll be met by a utility company specialist. This person will work with you to make sure that all of the contingencies you have discussed for this situation are addressed, so that the safest course of action can be followed in a dangerous situation. Power plants use some of the same equipment as found in a substation. The same guidelines apply in carrying tools and equipment. Be sure to keep everything at shoulder height or below. Before wrapping up, Let's review some key points. Put the following actions in the do or don't category. Leave power on as long as possible to provide visibility in fighting a structural fire. Do. Handle wires only when wearing approved safety insulation gloves. Don't. No gloves can provide completely safe protection from electricity. Once unoccupied, pull the electric meter to cut power to the structure. Don't pull out meters. Wait for utility personnel to cut power. When working inside, keep your palms facing in. Do. A shock will contract your muscles, moving your limbs away from the source. If you have the proper equipment, cut the service line to de-energize the structure. Don't. Leave this to the utility company. If you can locate a breaker box or panel, turn the main off here. Do, but be aware of backup systems which can still supply power. If you encounter a substation fire, what is the minimum safe distance for non-essential personnel? 100 feet? 200 feet? 300 feet? 300 feet. What kind of fire are you most likely to encounter in a substation emergency? Burning oil from inside breakers and transformers. In a substation or generating plant fire, all equipment brought inside should be limited to what height? Shoulder height, head height, doorway height. Shoulder height or below. When smoke and water vapor are dense, what dangerous situation arises around transmission lines? Ionization, phasing, arcing, grounding. The current can arc through flames and smoke to you and the ground.
Electricity is an unseen danger which can claim the life of a first responder in an instant. Your training conditions you to take action, and you may believe this is a reasonable risk associated with your work. Don't be fooled. Take the time to recognize all the dangers we presented, and then create an outcome which is safe for everyone, including yourself. Be alert, be prepared, and be safe.
Lights out.